Here we'll have discussion about acid, bases, and salts. These are the very important topics that we are going to discuss for the examination point of view, which is applicable for the all boards, including CBSE and all state boards. And here, if you see that this is just like operation of the NCERT, all key points, all concept is being discussed here. On the basis of that, you'll see that you'll able to answer all questions. So here in this, we are going to cover chemical properties of acid and bases. What is the pH factors? Okay. Again, what is the importance of the pH factor in our life? And what are the various salt formation takes place when acid and base are going to react? And what are the chemical from the common salt we are going to obtain? Again, we have crystal of the salts, like we'll have discussion about the gypsum and plaster of Paris. So these are the topics we are going to discuss inside this. So first we have what is the acid. So acid, how we are going to recognize that some substance is acid means it is sour in taste, that we are not going to use them, right? We are not going to taste. So for that, its property is that it will turn the blue litmus into red. Whereas the base, it is the bitter in taste. Again, we are not going to taste. Okay. So property is that it will turn the red litmus to blue. And we have various litmus solutions that is available in the natures. So what is the litmus solution? It is the purple dye and it's obtained from the plant lichen, that is from the Thallophyta family, which is the natural indicators, like we have turmeric, red cabbage leaves, colored petals of the flowers such as hydrangea, petunia, geranium. These are the natural indicators which is available in the nature. Apart from this, we have synthetic indicators like we have methyl orange and phenolphthalein. These two are the synthetic indicators. Okay. Next, we have chemical properties of the acid base, how it is going to react with different substance with different reactants that we are going to see here. So first we have when acid and base are going to react with metal, not with all metals. Okay, some metals are exceptionals. So that product is what here? Salt and hydrogen gas. So for this here, if you see that experiment setup here, we have zinc, in that we have diluted sulfuric acids. So after reaction here, hydrogen gas is being evolved. The presence of the hydrogen gas is being checked with the help of, when we bring here burning candles, so that hydrogen gas is going to burn with pop sound. So this also can be the one of the objective questions, how to identify presence of the hydrogen gas. So that is going to burn with the pop sounds. So here zinc and H2SO4 is going to provide the zinc sulfate, that is the salt, and we have hydrogen gas. Similarly, again, this is the basis. Sodium hydroxide is going to react with zinc. So in that case also we are going to get the hydrogen gas. So like this, one by one, chemical properties of the acid, base, and salts are being discussed here. Second properties, we have metal carbonates and metal hydrogen carbonates, that is the CO3 and SCO3, how it is going to react with acid. Here only we have taken the reaction with acid. So it is going to produce the salt and carbon dioxide and water. Since here what we have, this is the carbonates, metal carbonates, sodium carbonate here is going to react with HCl. So we are going to obtain the NaCls. So that is aqueous, it is soluble in the water, and we have water H2O, that is the liquid, and carbon dioxide gas we are going to obtain. Similarly, in case of bicarbonate or hydrogen carbonate here, when HCl is going to react, we are going to get the NaCl as the salt, and we have water as well as carbon dioxides. So in this setup, if you see here, we have in this setup, the sodium carbonate is going to react with the dilute HCl. So in this carbon dioxide, this gas is being evolved. That carbon dioxide gas, when it is going to pass over the lime water, that is the calcium hydroxide, then again it is going to change into calcium carbonate, which having a white precipitate and water molecule is also available. And again, if this calcium carbonate is going to mix with water and ability of the carbon dioxide is there. So it will convert into CaHCO3 whole 2, which is soluble in the waters. So this calcium carbonates, all this used in the whitewash also. So after 2-3 days, you'll get the signing of that one. So this is the one of the properties when acid is going to react with carbonate or hydrogen carbonates. Next, we have when acid and base both are going to react together. So in that case, again, it is being neutralized. Acid plus base. So we are going to obtain the salt with water. So sodium hydroxide is here base and HCl is the acid. So we are going to obtain the very popular sodium chloride that we use in the daily life, and we have water. So these are things we have to keep in mind when acid and bases are going to react, what we are going to obtain. Next, we have metal oxide plus acid. So when metal oxide is going to react, again you see that product is same salt and water. So finally, this metal oxide having same nature as the base. So that's why this is the metallic oxide is also called as the basis oxides. So here calcium, that is copper oxide plus HCl is going to react, so that we have CuCl2 plus water. This is the copper. Okay. Next we have non-metallic oxides. So non-metallic oxide again going to react with base. So it is same product here, salt and water. So that means non-metallic oxide is going to be act as the acidic in the nature. So that's why non-metallic oxide is also called as the having acidic in the nature. So here lime water is going to react with carbon dioxide. So then we are going to obtain CaCO3 plus H2O. So this is the CO2 is the non-metallic oxide. It is reacting with the base. Okay. So finally we have again white precipitate of this. So like this we have multiple properties on the basis of chemical reaction. Now here we are going to understand the main concept that all acids contains the hydrogen. So it will produce the hydrogen ions. So it is the positive ions, so which is called as the cation. Example are HCl, H3, H2SO4, CH3COH, which is the ethanoic acid. But all substance which having hydrogen, they are not acid. Okay, like we have glucose and alcohol. So how will come to know that acid or base is going to produce the ions? So here what will happen here in this experimental setup, if you see that we have either dilute HCl separately and we have NOH. These two are done separately. Okay. So when this ion formation will takes place, in case of HCl, we'll get H plus and Cl minus. In case of NaOH, we'll have Na plus OH minus. When separation of this ion will takes place, so finally movement will takes place inside the circuits, and finally this bulb is going to glow. So that shows that it is converted into form of ions. Similarly, all bases consist of OH ion. So OH ion is the negative here, so that is the anion. But similarly here, all substance which having OH will not be basis in the natures. So here examples of the basis is the NaOH and CaOH whole 2. So these are the chemical properties what we have seen so far. So next we have this acid and base, how it is going to behave in case of water solution. So here very important things we are going to discuss. Many times you'll get the long question on the basis of this. Why we should not put water in the acid, or why we should put acid on the water. So here if you see that in this experimental setups, they're trying to prepare the HCl gas. So here what we have first, sodium chloride is there. Sodium chloride is that is NaCl, which is soluble in the water. Now they are going to pour the H2SO4 slowly. Since when we are going to pour this acid in water or in aqueous solution, it's going to produce lot of heat. So that is the exothermic reaction. So sometimes, suppose for example, if you are going to pour it suddenly, it will damage the beaker also. So that's why we are pouring slowly. So the evaluation of this HCl here in this formation of in this reaction, when we are going to get the HCl, So that how we see, check the presence of the HCl. So here if you see that we have more moist, then it is going to react with litmus paper. Okay. Since in the presence of water, only it will release the hydrogen ions. In the absence of water, it is not going to release the hydrogen ion. Who is not going to release? HCl. So here sometimes if moisture is more, for that they're using the here guard tube containing the calcium chloride. So it is used to remove the moisture of the HCl. So here if you see in the reaction, when HCl having moisture, okay, then it is going to react with water and finally hydronium ion formation takes place and here chlorine is being separated. So again, that evolved hydrogen ion is going to react with water and continuous formation of the hydronium ion takes place here. So these bases generate the hydroxides in the waters. So the bases which is soluble in the water, they are called as the alkali. So now this alkali solutions, the bases which is soluble are soapy in touch and corrosive and bitter. Like here we have sodium hydroxide is going to mix with water. This is going to produce the Na plus, OH minus. Then you have KOH, K plus, OH minus, MgOH whole 2. This is the magnesium hydroxide that is also called milk of magnesia. So here Mg2H2 plus and we have OH minus. So this reaction here already we have seen earlier when acid and base both are going to react together is provide the salt as well as water. So this is the highly exothermic reaction where we are going to pour acid, okay, acid or base, anyone if you are going to mix with water is produce lot of heat, okay, that is called as the exothermic reaction. The reaction in which heat is going to be generated. Again, we have dilution. So that mixing of acid or base, when we are going to mix this acid or base with some water solution, so that will decrease the concentration. Okay. So that is called as the dilution. So due to mixing, it is going to decrease the concentration. Okay. So that since we should write here, since it decrease the concentration. So this one we have seen that how we should be careful when we are going to mix acid, base, even with water. Okay. Now we have very important thing that about the pH. Every time we are not going to taste the acid or base. So on the basis of that pH value, we are going to recognize about their nature. So this pH stands for potence, which is the German words. Okay, that's meaning is the power. And finally, pH is also called as the power of hydrogen. So here we are going to see the pH factors in the different situations. So what is the pH? It shows the concentration of the hydrogen ions. Here we have seen earlier that this hydrogen ion formation takes place and it will react with water is going to form the hydronium ion. So if you have higher value of the hydronium ion, then finally it will lower the pH value. Since pH is what? Concentration of the hydrogen ion. So pH is also given as equal to minus log base 10 concentration of this hydronium ion, or it is also can be calculated as pH equal to minus log base 10 concentration of the hydrogen ion. So here you will see that for the neutral solutions that pH value is the 7. When pH value is going to decrease, so finally, so pH value is going to decrease. But what is happening here? That concentration of the hydrogen ions are going to increase here. So when concentration of this hydrogen ions are going to increase, so that acidic nature is going to increase. So if you have more number of the hydrogen ions, so that will be more acidic in the nature. When pH values is going to increase, okay, so more than 7, so that means here we have hydrogen ion concentration is going to decrease. What is going to increase? Concentration of OH minus is going to increase. So due to that, the basis nature is also going to increase. So here if you see that range is 0 to 7 in this solutions are acidic, more than 7 and around 14 it is called as the basis in the natures. So for these some common solutions, or in the daily life what we are using. For that here pH factor is given, so that you need to remember. Sometimes you'll get the objective question on this. So pH of the water, okay, pure water as well as human blood is how much? 7.4. So it is little bit, okay, basis in the nature. And neutral is what? 7. Lemon juice is more acidic, that is 2.2 pH values, and gastric juice, that is the about 1.2. And here milk of magnesia, pH is the 10, so that is the basis in the natures, which is used in the antacids to neutralize the acidic effect. Again, we have sodium hydroxides, that pH value is 14. So these are the pH value you need to remember. It will be useful in the exam. Direct, you can answer the questions. Next, we have how these pH are important in our life. What is their important? How we are going to utilize that for our safety and for different treatments. So normally the pH of the human body is 7 to 7.8. In case of acid rain, sometimes if you are heard about acidic rain, so that means pH value is less than zero point 0.6, sorry, 5.6. Okay, so that is acidic in the nature. So if you have heard about the Venus planet where life is not possible, it has white and yellowish cloud of sulfuric acid. So that environment is what? Acidic. So that pH value will be how much? It will be less than 7. Whereas pH of the soil, it is very important for the agricultures when we are talking about the different plants. So most plant having a range 6 to 7.5. So it is from acidic to slightly alkaline solution. And in case of some plants are acid loving plants, so in that case, its pH value is 4.5 to 5.5. So here some examples like blueberries, all these things are the acidic in the natures that required soil little bit more acidic. Whereas some alkaline tolerant veggies are available, like we have spinach, beets, okay, they required alkaline soil, that is the pH is 7 to 8. Whereas pH in our digestive system, so our stomach is going to produce the acid, that is the HCl. So that is helpful in the digestion. But when we have excess of this HCl formation takes place, to neutralize this acid, what we require? Acid will be neutralized by the base. So that will get the salt, okay, plus water. So this HCl is the acid, so that in market antacid is available as the medicine, and one of the main component of antacid is the magnesium hydroxide, which is also called as milk of magnesia. It is the mild base, so which is used to neutralize the acid. And tooth, that every morning we were going to clean our teeth even before sleeping. So teeth starts decay. If it will become acidic, that means its pH value is going to be less than 5.5. And enamel is the hardest substance of our body which is available in the teeth, and it is made up of the calcium hydroxide peptide. So it is the crystal from the calcium phosphates. So this is also very important, enamel. Okay, so it is the hardest substance of the body. So for the different values for different applications, what we are going through every day in the life, their pH values are given here. Next, we have how these plants or living organism use this concept for their self-defense. So here, one example is given. Suppose, for example, when bee is going to sit on some plants, so it's or it's like it's going to sit on our skin somewhere. So it's leave acids. So due to this acid, we get the pain. And if you'll apply some basic solution, like we'll apply the baking soda, so it will neutralize the acidic effect. And so this is the nettle leaves which is available in the nature. It has, if you touch means, we'll get this methanoic acids. Due to that, we'll get the irritation. And to neutralize this, if you'll apply the leaf of the dog plant, then we'll get the relief from this. So this nettle leaves and this dog plants both are available in the nature near. So now here some substance is given. So some substance are given for that what are the acidic nature here, like vinegar acetic acids, okay, orange citric acids what we are using daily life, tamarind tartaric acids, T4T like this you can remember. Tomato, we have oxalic acid, tomato O, and here O, sour milk or curd, what we use in daily life, that having lactic acid, and you about the lactobacillus bacteria also. Lemon, okay, that we also use very many times. So that having citric acid. Ant sting, when an ant is going to bites, here is going to generate the methanoic acids, or nettle sting, it's also going to produce the methanoic acids. So these are the things which is available in the natures and which having different acids, that also we need to remember for the objective questions. Now here we are going to see the salt and their families. So how we are going to obtain the salt, and on the basis of their reactants, their name is given. Okay. So like here we have potassium sulfate, K2SO4. It is called the salt of the potassium family. Why means here we have this salt we are going to obtain due to the reaction of this H2SO4 plus KOH. So similarly, we have sodium phosphate, that is the sodium salt family, calcium sulfate from the calcium family. So all these reactants are written here on the right side, how we are going to obtain this salt. So on the basis of their reactant properties, what are the reactants are available? Like sodium carbonate is the family of the carbonate salts. Okay. So here if you see that who is going to dominate, on the basis of that also name is given here. Okay, sometimes if you see that it has the name is given on the basis of the basis, sometimes it is given on the basis of acidity. Okay, so that here main concept is what here, if a strong acid and a strong base both are going to react, so it will produce the neutral salt. So neutral salt means pH value is the same. When we have a strong acid plus weak base is going to produce the salt, that is acidic in the nature, so pH is the less than 7. And when we have weak acid, okay, weak acid I will react with weak a strong base. So what we'll get here, salt will be the basis in the nature. So that basis in the nature means that pH value will be how much? More than 7. So similarly we'll have, so this is the basis in the nature. So next we have some other properties. There's some common salts what we are going to obtain here. So now here we have chemicals from the common salts. So common salt is what? Sodium chloride. So by using sodium chlorides, what are the things we are going to obtain? So first and important is the sodium hydroxides. So here if you see that when we have experiment setups, that is the chlor-alkali process. So this chlor means here evolution of the chlorine gas takes place. Okay, and this is alkaline in solutions, which is soluble in the water. So finally here in this setup, if you see that left side, what we have? Brine. So brine is the highly concentrated sodium chloride water solution. So now in this, what is happening? Now due to this electrolysis process here, this NaCl is being separated. In this NaCl, what we have here, Na plus and Cl minus. Okay. And similarly, what we have, since it is the reaction in where? In the water. So this water molecule is also going to separate into H plus and OH minus. So finally, what we are seeing that this cation moves towards the anode, and whereas cation moves, this is the cation. When we have positive ions, okay, so these positive ions are called as the cations. So that's cations moves towards the cathode having negative in nature, whereas the anion is the negative ions. So this anions moves towards the anode. Okay, so finally here we are going to obtain the chlorine gas, which is used for the water treatment in the swimming pools also, and PVC is the polyvinyl chloride, and it is also used as disinfectants in chlorofluorocarbon CFC and in pesticides. So this chlorofluorocarbon we are going to obtain from the refrigerator also, and here we are going to obtain the hydrogen gas that is used as the fuels, and methane in case of ammonia for the fertilizers. So some fertilizers are the rich in the ammonia. And finally, we are going to obtain here NOH, that is the sodium hydroxides, which are used for the degrading metals in the soap formation, in detergents, in paper making, in artificial fibers. So each and every products are very, very important that we are obtaining from where? From the common salt, sodium chlorides, when it is going to react with water. So we have here sodium hydroxides and chlorine gas as well as hydrogen gas. So this is the very, very important setups for the examination point of view. Each and every outcome of these are very important. Next, another is the bleaching powder. That also we use in the common life. Okay. So this bleaching powder, how we are going to obtain when dry select lime is going to react with chlorine. So this chlorine, what we have obtained in the previous process, same chlorine can be used here, and finally we are getting the bleaching powder. Okay, so CaOCl2 is the formula for the bleaching powder, and we are going to get the octanes water also. So it's the formula we need to remember. Okay, CaOCl2, how we are getting when calcium hydroxide is going to react with chlorine, or this obtained chlorine gas is going to pass over the dry select line. And it has various uses, like in the textile industry for the bleaching of the cotton and linen, in paper industry for the bleaching of the wood pulp, in case of laundry again bleaching of the washed clothes, in chemical industry it is used as the oxidizing agent, and in the drink it is also used to purify the drinking water to make it free from the germs. Another, now we have baking soda. Okay, so here how NaCl is evolved in this bleaching powder means, if you have seen the previous experiments activity, in that due to NaCl plus H2O, we are going to obtain sodium hydroxide, and we have chlorine gas, and we have hydrogen gas. So this chlorine is being used here. Okay. So that's why it is also one of the outcome due to the natural salt which is we are using mostly. Next we have baking soda. So it is the mild non-corrosive basis salt. So this is we are using directly, indirectly in many food products here. So this sodium chlorides is going to react with water, carbon dioxide is also there, and NH3 is also. So finally we are having product here NH4Cl and HCO3, that is the sodium hydrogen carbonates. So it is used, okay, in many places to make the first use we are seeing here, that is the making the baking powder. So this baking powder, how we are going to obtain this baking soda, is going to react with mild acid. Maybe we are going to use the tartaric acid. That tartaric acid we have seen earlier, it is used in the tamarind. Okay, now when this obtained, this is the formula for the baking soda. So when this baking soda is being heated, when we are going to use this one, it is going to produce carbon dioxide gas as well as water. So this, due to this carbon dioxide gas, our substance is going to become more soft and spongy. And apart from this, further you are seeing that NaHCO3 is going to react with hydrogen ion. This hydrogen ion is obtained from where? From any acetic solution. Okay, like suppose HCl. So from there, H plus Cl minus is being separated. So due to this carbon dioxide, it is making our product soft and spongy, like for the cake and other things we are using. And it is also one of the important ingredients of the antacids. So antacid purpose is to neutralize the acids. So that means it is the basis in the nature. So it is also used in case of soda acid fire extinguishers. So you must have to remember the formula of bleaching powder, baking soda, as well as what are their uses. So these questions are going to come for this year. Okay. Next we have washing soda. So washing soda, sometimes people get confused. Baking soda. Baking means is used for the baking, means in the kitchen, in the for the cooking purpose. And this washing soda is going to use as the in the detergent. Name itself is the washing soda. So it has, if you see that Na2CO3 is going to react with water. So here we have Na2CO3 dot, that is the per multiple with water. So finally here concentration of the water molecules. So here it is the 10H2. Okay. So that concentration of, if you see that in this, you can decide here whether it will be wet or dry. So here it has water molecules are here more. Okay. That is the 10H2O. So that's why it's going to be wet in the natures. And later we'll see the process, how we can make dry. That process we are going to see. So again, what is the uses? What are the various uses of the washing soda? So it is used in the glass, soap, and paper industries. And it is also used for the manufacturing of the sodium compounds such as borax. And it is one of the cleaning agent for the domestic purpose. And it is used, vital use to remove the permanent hardness of the surface. So due to permanent hardness, if you see that even hardness of the water is there, it will not be suitable for the cleaning of cloths also. So these are the main outcome, main salt that we are going to obtain, okay, from the common salt. And finally, what are their uses? Next, we have crystal of salts. So this crystal of salts, these are also very important in the daily life. Okay, so that we are going to see here. So that crystal of salt, so here we have hydrated copper sulfate. So here CuSO4, and here you are seeing that it is 5 times of the water. So this is the how much water molecules are available here. So it is blue in color in general, okay, but when it will lose the water, it will turn into white. So here if you see the setup here, so here we have copper sulfate crystals, okay. So this copper sulfate crystal, initially it will look blue, but when we are going to heat this one, so finally water droplets are being removed, that you can see from here. Okay, so this water droplets will be removed. So finally, what will happen? After that, its color will change into white. Okay, so now here another crystal is the gypsum. It is also very important. Okay, so it possesses the water of crystallization. So here we are seeing that calcium sulfate having two molecules of the water. Now this gypsum, how we are going to use, that is important. So this is the plaster of Paris. So why it is called as the plaster of Paris means it is obtained from the gypsum, that is obtained from the Montmartre district of the Paris, which is in the France, that you know very well. So that's why its name is given plaster of Paris. So this plaster of Paris is obtained from where? From the gypsum. That is uh, first time they have obtained in the Paris, so name is given plaster of Paris. Sometimes maybe they will ask why it is called as plaster of Paris. So it is obtained by heating the gypsum at the temperature of 373 Kelvin. So here you are seeing that we have two water molecules and here we have only half water molecules. So that formula of the plaster of Paris is CaSO4 dot half H2O. So that means 1 unit of the calcium sulfate having half molecule of the waters. So in case of 2 units of the calcium sulfate, it will become 1 molecule of the water. So that is the calcium sulfate. It is hemihydrate since here we have half molecule of the water for 1 unit of the calcium sulfates. So what are the uses? So doctor use for the plastering the some fractured bones to give the supports. So it is when it is going to mix with waters, it will turn into the gypsum. So this is the formula for the gypsum. And it is also used for the making of toys and to make some decorative materials as well as to making the surface smooth. So here you are seeing that left side we have the setups that used to remove the water molecules from the crystal. So these are the discussion about acid, base, and salts, and where we have seen some important formulas, some reactions. Okay, so this is very important for the examination point of view, as well as you need to remember the pH factors. Okay, thank you very much. Like,